or alpha plus beta flips. Okay, so you can assume, okay, because originally, if you don't know anything about this problem better, okay, sometimes you want to use, because you are going to use alpha and beta or A and B to describe your belief, right? Okay, so remember, we say, okay, I mean, you get this coin, okay, from bank, okay, so you have maybe like a moderate, confidence that it is fair. But how do you describe, I mean, that using the beta distribution? You can do it something like this. Okay, if you have no prior knowledge over, then the knowledge that the coin has a head side and the tail side. Okay, you know nothing about this coin. Okay, you don't even know where this coin comes from, but you know it has two sides. Okay, then you can say, okay, you can set like alpha and the beta both to be 1. Okay, in that case, okay, your prior will be uniform distribution. Okay, here, this one. Oops. This one, the flat one. Okay, so this is when alpha and beta are both 1. Okay, well, because you know, well, we have a tail, we have a head, and well, you can assume that you have flipped this coin twice, and you get 1 head and 1 tail. That's pretty much about it. Okay. So, okay, if you think that the coin is probably fair, it's probably fair. Okay, as I said, we get it somewhere. Okay, maybe from the bank, but it's not directly from the government. We are not very sure. Okay, then we can imagine that the previous observed data had, say, alpha and beta both to be 4. Okay, here we are describing, you know, not so confident faith that this coin is fair. Okay, we believe coin is fair, but we are not so sure. Okay, because remember, when both alpha and beta are the same value and they are larger than 1, then it means that we have a bulk. We have a bulk at the middle, right? If you look at the diagonal figure, okay, especially like the lower right one, it's alpha equal to 3 and beta equal to 3. I mean, as alpha and beta are both to be 4, you can imagine this bulk will become even more obvious, right? Okay, it's going to be more concentrated. The distribution is going to be more concentrated on 0.5, but just a little bit more concentrated, not so concentrated. Okay, because you can see the trend. Yeah, it's going to be a little bit more concentrated, but you know, just adding one to alpha and beta. Okay, I mean to the lower, I mean right corner. Okay, case. I mean it's not going to affect that too much. Okay, so but still it describes a mild belief that the coin is fair, right? So, so often we think of our prior belief in terms of central tendency and the certainty about the central tendency. Okay, so central tendency and the certainty about the central tendency, they are two things. Okay, central tendency describes like where the center should be located. Okay, and certainty about the central tendency is how concentrated your distribution should be, okay, to a particular center. Okay, so if we use like traditional statistics as an example, the first term normally can be considered as mu, okay, the average, okay, And the certainty about the central tendency, a lot of time we consider that in the traditional statistics as sigma, the standard deviation. Okay, as you know, like when standard deviation is large, like the figure will be more concentrated to the mean, right? We know that, right? Okay, so so actually, okay, in thinking about probability of left-handedness, okay, in the general population of people. So, by the way, how many people in this class are left-handed? Do you mind like raise your hand? Only one. Yeah, two. Okay, so I mean this is like a cultural issue. Okay, I mean like in Eastern culture. Okay, the parents sometimes don't like their kids to be left-handed. So even if you are left-handed, okay, when you are little, okay, the parents may, correct it, okay, in the sense that the parents will force you to use the right hand, and but really like in other countries, especially Western country, I mean the left-handedness, okay, is not an issue. Okay, they consider this as just like like hair color, okay, like or like eye color, okay, just attribute, okay, of a human, and it is very convenient, okay, in as far as I remember, like when I was in U.S., okay, even though I'm not left-handed, okay, I know like there are a lot of places that sell like items, especially designed for left-handed people. So it's very convenient, to be left-handed in Western country. Unfortunately, in Taiwan or in most of like Eastern countries, like you see like left-handed people, like ratio is very low. Okay, it's not really. It's really because like the cultural issue. Okay, so see, okay, from everyday experience that is around 10%. The left-handed population. This is the case in Western country, not in Eastern country. Okay, so if I'm not very confident about that value, we might consider equivalence. Previous sample size to be small. For example, n equal to 10, which means that of 10 previous observed people, one of them was left-handed. Okay, so how do we set up alpha and the beta value for a beta distribution to describe that? Okay, in this case, the alpha, you can set alpha to be 1, beta to be 9. Okay, it's kind of just like you have 10 trial, and out of those 10 trial, 1 is left-handed. Okay, so 1 is like so A or alpha is 1, B or beta is 9. Okay, or in thinking about the probability that a government minted coin come up heads, okay, such a probability should be very, very near 50%. Okay, so because we are fairly certain, okay, we can set this equivalent previous sample size, okay, to be maybe n equal to 100. So here, okay, what do we use to describe this the certainty about the central tendency? It's the value of n, which is the sum of alpha and beta. Okay, if you are not so certain, you can set n to be smaller. If you are pretty sure, for example, like you consider the government minted coin, okay, is pretty fair. Okay, you can set n to be 200. In this case, of course, because it's fair, so you have half of the them to be A and half of them to be B. Or let me put it this way: you can sort of consider A or alpha to be the number of flips that come up head, and the B or beta to be number of flips that come up tail. Okay, so you can use that, okay, to determine the A and the B or alpha and beta value, for your prior distribution. Okay, so our goal is to convert the prior belief expressed in terms of central tendency and the sample size. Okay, so using the A and B value, okay, in the beta distribution. So in that case, as I said, we normally consider the central tendency as a mu, the average, and the standard deviation to describe the certainty of that central tendency. Okay, so for beta distribution, okay, the mu is actually A divided by A plus B. Okay, so so you can see that, okay, it is very reasonable, okay, to consider A is 1, the B is 9 in the first case, okay, that to describe like a portion of left-handed people, right? Because the mu is going to be 1 over 10, okay, which is the 10%, right? And the omega. So what is omega? Omega is the mode, okay, mode, okay, 众数. Omega is mode, okay. You could describe central tendency using two different ways. The first way is to use the mu, the average, or expected value, okay. The second one is the mode, okay. Either one works, okay. Either one works fine, okay. And for mode, it's a little bit more complicated. It's A minus 1 divided by A plus B minus 2, okay. For if the A and the B are greater than 1, okay, which is normally always the case, okay. So, and by the way, when A and B are the same, okay, we know beta distribution will be symmetrical, right? When beta distribution is symmetrical, obviously you can imagine the average will be the same as the omega, okay, 众数跟平均会一样, okay. So when A equal to B, the mean and the mode are 0.5. You can actually calculate that easily, okay. So when A greater than B, obviously the mean and the mode are greater than 0.5. When A smaller than B, the mean and the mode are less than 0.5. You can verify that easily by using the above equation, okay, or by observing the figures here, okay, very easily, okay. So, okay, and the spread of the beta distribution, okay, how certain you believe the central tendency is related to concentration, okay. The concentration, we say this concentration is A plus B. We give it a particular name, okay, to this value. We say this is kappa, okay. The kappa describes how concentrated, okay, your beta distribution is, okay. So as kappa gets larger, the beta distribution will be, more concentrated toward the center, okay. And obviously you can, when you have the mu and kappa, okay, you have a mu and the kappa, you can get your A and B value, okay? So A will be mu times kappa, B will be 1 minus mu times kappa, okay? So this is the case when you have mu and kappa. But to be honest, kappa is really not something that you that can be described like intuitively. A lot of time, maybe what you have, okay, is something different. We'll talk about that later, okay? But if you have the omega, okay, omega actually is more intuitive than mu. Why? What is mu? Mu is the average, right? So when the distribution is not symmetrical, okay, the average normally will not be the highest place in the distribution, right? Okay, for example, if I have a distribution like this, you can imagine the average, okay, will be, this is the highest point, okay? But the average of this distribution should be somewhere here, right? This may be your mu, this will be your omega, right? So omega is more intuitive. In a sense, it represents the highest point, the place that will give you the highest point in your distribution, right? So omega, okay, if you have the omega and the kappa, okay, we also have the formula that tells you how you can set up your A and the B, okay? I mean, omega times kappa minus 2 plus 1 is your A, and you can set B to be 1 minus omega times kappa minus 2 plus 1, okay?